discovered recently called the Worldwide Telescope. The view that I am showing here is as if we were at the center of the Earth. So this line that goes across the center of the screen, that's essentially the equator. Anything north of that is the northern hemisphere. Anything south of that is the southern hemisphere. If I scroll all the way up to the top, you can see the North Pole would be right up here in the center of that circle, and the South Pole is down here at the very bottom. So essentially, we are sitting in the center of the Earth looking outwards. Now, this big structure going across the screen diagonally, of course, is the Milky Way Galaxy, which we are inside of. And if you scroll around on the Milky Way Galaxy, you see it becomes more faint over here on this side. This is the outer part of the galaxy. It's looking out towards the edge of the Milky Way Galaxy. As it gets brighter, as you come around to this side, in the southern hemisphere, you can see it's very bright. In fact, right over here, it's exceptionally bright. This very bright area is the center. We're looking towards the center of the Milky Way Galaxy, which is where the supermassive black hole at the center of our galaxy exists. If you're in the northern hemisphere, we still see some bright areas and whatnot, but not quite as bright as the southern hemisphere. So if you're in Australia, or if you're visiting, some area in the southern hemisphere of planet Earth, you're going to see a much, much brighter Milky Way at night than you do in the northern hemisphere. As an example, here's a photo that I took of the Milky Way Galaxy in the Boundary Waters Canoe Area Wilderness in northern Minnesota. So you can see this. You can see the Milky Way stretching off into the distance here. Below the horizon, it would be much, much brighter, as you can see right here. So now that we've established our bearings, let's take a look at some of the objects that were recently revealed by the James Webb Space Telescope. The first one is probably the image that got the most attention right away. Actually, we'll come to that one later. That one is the zoomed in image of all the very distant galaxies. Instead, let's look at the Carina Nebula. So we'll find the Carina Nebula. All the images I believe that Webb took were in the southern hemisphere, so you can see we're facing very far south in this image. So Webb is actually pointing very far towards the southern hemisphere, or the southern end of our viewing area, to get this image. So this is the image, the Carina Nebula, kind of oriented where it would be among the cosmos, and when we zoom back out, we get a true scale of how zoomed in that really is. So as you can see, the Carina Nebula is actually a star-forming region that is actually within the band of the Milky Way. You can see that if we're zooming in on the Milky Way, we're not zooming in on a dark area outside the Milky Way. These background images look kind of fuzzy just because the background imagery for this particular tool isn't fully detailed, and what they do is they position the high detail images on that background where they exist. So this is exactly where just a portion of the Carina Nebula would exist in this area here. So we can actually maybe find some other pictures of the Carina Nebula. I think this is, yep, there we go. So there's a picture of the full nebula. The actual part of the image that James Webb, the image that James Webb took, this colorful one that we're all used to seeing, actually exists in this upper corner right here of the Carina Nebula. So if we put that right there, you can see it's just a tiny chunk. It's just a tiny chunk of that nebula. Pretty dang cool. Pretty amazing. So if we zoom out here, again, it's just a cloudy, star-forming region of the Milky Way Galaxy. Pretty neat. Another object, or another region of space that, of course, has gotten a lot of attention and represents the deepest that we've ever been able to look into the galaxy, or into the cosmos, the universe, is this image right here that we're all familiar with seeing now. Again, this is a very southerly facing image. You can see it doesn't exist within the Milky Way, though. It's just in some random dark place in the sky. And that's one of the reasons why originally, when this image was taken by Hubble, not the James Webb Space Telescope, but they just focused the telescope on a very, very dark part of the sky that they believed had nothing in it. If you zoom in and you zoom in and you zoom in, it apparently they were zooming in on an area that had no visible light, no visible stars. But when they let the camera, or the sensors on the Hubble and of course on the James Webb Space Telescope, sit there and just image for hours on end. I think James Webb had to spend about 12 and a half hours producing this image, whereas Hubble had to do weeks of exposure to get a very similar image to this. So what's really fascinating about this is not, these big bright stars. These bright stars are actually much closer. Those are between us and these distant galaxies. All these other objects, even these weird swirly ones, are galaxies. Sorry, excuse that pop up. That's a work pop up. There is an incredible number of galaxies here, and the really amazing thing is that even these really, really, really faint dots, like these ones, like this one here and this one here, and everything you see that is light in this image that doesn't have the spikes coming off it like this, each one of those is a galaxy. And as far as we know, these are some of the very first galaxies ever to be in existence in the universe. We're looking back about 13 billion years here, and we're seeing these objects as they existed 13 billion years ago, not as they exist today, simply because it's taken that long for the light to reach us. Fascinating. I mean, it is absolutely incredible to look at this image, which contains easily 1,000 galaxies, probably more. There may even be galaxies here in between these galaxies that we can't quite see yet, like right in here. Like there's this really faint object right here, and another really faint object right here. If we focus in on one of these areas where we don't see any light, like maybe right about here, and we zoomed in even further, or maybe we did a longer exposure with the James Webb Telescope, we might even see more galaxies emerging in the image in that area too. So when you take this image and you zoom all the way back out, and then you realize that every single area of the sky that we look at looks like this. This is not just this one region of space that looks this way. Every single part of the sky is crowded with galaxies in the same way. It really makes you realize how absolutely enormous the universe that we live in is, and how unbelievably small we are, and how incredible it is that we can even look at these things and make any sense of them whatsoever. It is absolutely fascinating to me, and I think it's one of the most important things we do as a species is try to understand our place in the cosmos and in the vastness of reality.